And now in this lecture we'll find out the radius of a circle. In the moment we have a circle. Inside the circle we have chord DB. This is equals to 2 units in length. We have also chord AC. This is equals to the square root of 2 units in length. We have also chord AB and chord DC. And finally, this is angle DEB. The size of this angle DEB is 45 degrees. Again, our mission is to find out the radius of this circle. So, in the first step, we'll join points D and A together by a straight line. By joining points D and A, we created peripheral angle. This is peripheral angle DAB. This peripheral angle DAB is subtended on chord DB. I repeat again, peripheral angle DAB is subtended on chord DB. We define the side of this peripheral angle DAB as x over 2. Which again, according to our definition, the size of this peripheral angle DAB is equals to x over 2 degrees in its size, and this peripheral angle DAB is subtended on chord DB. We define the center of this circle, this point, as point O. In the next step, we join points O and D together by a straight line. Likewise, we join points O and B together by a straight line. By doing this construction, we can deduce central angle DOB. This is central angle DOB, and this central angle DOB is subtended on chord DB. So both those two angles, they subtend on the same chord called DB. And for that reason, we can implement here Rule 13. I'll repeat quickly on Rule 13. According to Rule 13, a central angle is twice as large as the peripheral angle subtended on the same chord. So in the moment we have a circle. Inside this circle we have, this is peripheral angle ACB. This is peripheral angle ACB. The size of this peripheral angle ACB is theta, and this peripheral angle ACB is subtended on chord AB. Again, peripheral angle ACB is subtended on chord AB. Likewise, we have also, this is the central angle AOB. The central angle AOB is also subtended on the same chord called AB. Exactly like peripheral angle ACB, this is also subtended on the same chord called AB. So, those two angles, they are both subtended on the same chord called AB. And therefore, according to this Rule 13, the size of the central angle AOB must be twice as large as the size of this peripheral angle that is subtended on the same chord called AB. So the size of peripheral angle ACB is theta, and therefore the size of this central angle AOB that is subtended on the same chord called AB must be equal to 2 theta. Okay? So the size of a central angle is twice as large as the size of a peripheral angle that is subtended on the same chord. This is Rule 13. So we can actually implement Rule 13 in our drawing. Why? Because in our drawing we have here, this is peripheral angle DAB, and this peripheral angle DAB is subtended on chord DB. Likewise, this is the center angle DOB. The center angle DOB is also subtended on the same chord called DB. And therefore, according to Rule 13, the size of this center angle DOB it must be twice as large as this peripheral angle DAB that is subtended on the same chord called DB. So the size of this peripheral angle DAB is x over 2, and therefore the size of the central angle DOB that is subtended on the same chord called DB must be equal to x. Exactly twice as large as this peripheral angle, that is x over 2. So the size of the central angle DOB is x according to Rule 13. Likewise, we will define the size of this peripheral angle ADC. This is peripheral angle ADC. We will define the size of this peripheral angle ADC as y over 2. So we have here peripheral angle ADC that is subtended on chord AC. This peripheral angle ADC, the size of this peripheral angle ADC is y over 2 according to our definition. In the next step, we join points O and C together by straight line. Likewise, we join points O and A together by straight line. Actually, by doing these constructions, we created here central angle COA. This is central angle COA, and central angle COA is subtended on chord AC, exactly like peripheral angle ADC. It is also subtended on the same chord called AC. So those two angles, they are both subtended on the same chord called AC, and therefore, according to Rule 13, the size of this central angle AOC must be twice as large as this peripheral angle AOC. The size of this peripheral angle AOC is y over 2, and therefore the size of this central angle AOC that is subtended on the same chord called AC must be y, exactly twice as large as the peripheral angle, this peripheral angle AOC that is y over 2, and therefore the size of the central angle AOC that is subtended on the same chord called AC, it must be equals to y degrees in its size. In the next step, I'll copy triangle AED, this triangle AED in a new page, and we'll implement Rule 4 in this triangle AED. So actually, this is triangle DEA with the common from the horizontal drawing. Inside triangle DEA, we have those two angles. Actually, all the three angles, those two angles plus this angle, that is angle DEA, they are all defined as the interior angles of this triangle, triangle DEA. So I write it down. Those two angles, they are both defined as interior angles of this triangle, triangle DEA. So I write it down. Those two angles, x over 2 and y over 2, they are both the interior angles of this triangle, triangle DEA. Interior angles. While this is angle DEB, and this angle DEB is not located inside triangle DEA, and therefore it is defined as an exterior angle of this triangle, triangle DEA. So write it down. So this angle, this is actually angle DEB, is defined as an exterior angle of this triangle, triangle DEB. Well, because it is located outside triangle DEA. Now, I will present to you rule 4, and we will implement rule 4 in our drawing. So, according to rule 4, the exterior angle of a triangle is equal to the sum of the two interior angles that are not adjacent to it. So in the drawing we have a triangle. Inside this triangle we have those three angles A, B and C. They are all defined as interior angles of this triangle because they are located inside the triangle. So, and especially angles A and B, they are both interior angles of this triangle, triangle ABC. And this is angle E. It is located outside triangle ABC, and therefore it is defined as an exterior angle, angle E. And according to this rule 4, the size of this exterior angle, angle E, is equal to the sum of the two interior angles that are not adjacent to it. We have three angles, A, B, and C. They are defined as an interior angles of this triangle. And this is angle C. It is an interior angle that is adjacent to this angle, angle E. The two other angles, A and B, they are not adjacent to this angle, angle E. And the sum of the two angles, those two angles that are not adjacent to angle E, the sum is A plus B. So the size of this exterior angle, angle E, is equal to A plus B. Or the size of this angle, the exterior angle, angle E, is equal to the sum of the two interior angles that are not adjacent to it. And the two interior angles that are not adjacent to it are A and B. And therefore the size of the exterior angle E equals to A plus B. Then again, the size of the exterior angle E is equal to the sum of the two interior angles that are not adjacent to it. That is to say, the size of angle E is equal to A plus B. Okay, so we can actually implement rule 4 in our drawing. Why? Because in our drawing, this is the exterior angle, angle BED is defined as an exterior angle of triangle DEA because it is not located inside triangle DEA. So the size of this exterior angle DEB is equal to the sum of the two interior angles that are not adjacent to it. This is angle DEA that is adjacent to this angle DEB, and the two other angles that are not adjacent to it are those two angles, x over 2 and y over 2. And therefore, according to rule 4, the size of the exterior angle BED, it is equals to x over 2 plus y over 2. And then again, according to rule 4, the size of the external angle BED is equals to x over 2 plus y over 2. So I write it down. I should find out that according to rule 4, the size of the external angle DEB is equals to the sum of the two angles that are not adjacent to it. The two angles that are not adjacent to it are x over 2 plus y over 2. So the sum of the those two angles is x over 2 plus y over 2. And it is equals to the size of the external angle DEB. According to rule 4, of course. It is given as a question that the size of the external angle BED is 45 degrees. So we can substitute angle DEB by 45 degrees. So we can find out that 45 degrees equals to x over 2 plus y over 2. Here we multiply this equation by 2. We get that 45 degrees times 2 is 90 degrees. So 90 degrees equals to x over 2 times 2 is x and y over 2 times 2 is y. So in conclusion, we should find out that x plus y equals to 90 degrees. Here we subtract x from this equation and finally we get that y equals to 90 degrees minus x. This is equation 1, so according to equation 1, y equals to 90 degrees minus x. In the next step, I'll copy this triangle DOB in the new page, and we will implement the law of cosines in this triangle DOB. But before that, I will present to you quickly, repeat quickly on the law of cosines. First of all, the law of cosines is true in any triangle. So this is triangle ABC, that could be any triangle. So in any triangle, so we have here triangle ABC, the size of side AB is A unit, side AC equals to B units in its length, and side BC equals to C units in its length. And this is angle BAC, the size of angle BAC is theta. According to the law of cosines, in this triangle ABC that could be any triangle, cosine theta equals to A squared plus B squared minus C squared over 2 times A times B. Again, cosine theta equals to A squared plus B squared minus C squared over 2 times A times B. Okay, so we can actually implement the law of cosines in our drawing. So the law of cosines is true in any triangle. So we will implement the law of cosines in this triangle DOB. So I'll copy this triangle DOB in the new page, and we will implement the law of cosines in this triangle DOB. But before that, what is the definition of line segment OB? Line segment OB starts from the center of the circle, that is to say from point O, and ends at point B, that is the point of the circle itself. So this is exactly the definition of a radius. Therefore, OB is the radius of this circle, that is the radius that we are looking for in this question. We define the radius of this circle as R, therefore OB equals to R. OB equals to R. Likewise, OC also equals to R. OA also equals to R. And finally, OD is also equals to R. So in the next step, I'll copy this triangle DOB in a new page, and we will implement the law of cosines in this triangle DOB. Side DB of triangle DOB equals to 2 units in itself according to what is given as the question. So actually, this is triangle DOB, this is the coordinate from the original drawing. This triangle DOB, sides OB and OD, they are both the area of the circle, is equals to R, and side DB equals to 2 units in itself. It's left according to what is given as the question. And this is angle BOD, that is equals to X. So according to the law of cosines, in triangle DOB, the following equation will be true. Cosine X equals to DO squared, but DO is out, therefore DO squared is R squared, plus BO squared. BO is out, therefore BO squared is R squared, minus BD squared. BD is 2, therefore BD squared is 2 squared, that is 4, so it is minus 4, divided by 2 times DO. DO is out, therefore we substitute DO by R, so it will be 2 times R, times OB. OB is also R, so we substitute OB by R. We shall find out that according to equation 1, cosine X equals to R squared plus R squared minus 4 over 2 times R. R squared plus R squared is 2R squared. So in total, in the numerator of this expression, we have 2R squared minus 4 divided by 2 times R, that is 2R squared. Okay, so here we shall find out that according to equation 1, cosine X equals to 2R squared over 2R squared is 1. We have also minus 4 over 2R squared. So cosine X equals to 1. And here we have minus 4 over 2R squared. So here we divide both the numerator and the denominator of this expression by 2, and we get that minus 4 over 2 is minus 2. And 2R squared over 2 is R squared. So if I found out that cosine X, according to equation 1, cosine X equals to 1 minus 2 over R squared. In the next step, I'll copy the right triangle ACO, this right triangle ACO in the new page, and we'll implement the law of cosines in this triangle ACO. Side AC equals to the square root of 2 units in itself, according to what is given as the question. Side AO equals to R, and side CO also equals to R. And this is angle AOC, The size of angle AOC is y. So actually, this is triangle AOC that is coming from the original drawing. According to the law of cosines, this triangle AOC, cosine y equals to AO square. AO is out, therefore AO square is R square plus CO square. CO is also out, therefore CO square is R square minus AC square. AC is square root of 2, therefore AC square is square root of 2 squared, that is 2. So it is minus 2 divided by 2 times AO. AO is also substitute AO by R times CO. CO is also R, therefore we substitute CO by R. So in conclusion, according to equation 2, we shall find out that cosine y equals to R square plus R square minus 2 over 2 times R times R. R square plus R square is 2R square. So total in the numerator of this expression, we have 2R square minus 2 divided by 2 times R is 2R square. So here we have 2R square over 2R square is 1, and also have minus 2 over 2R square. So if I found out that cosine y equals to 1, and here we have minus 2 over 2R square. Here we divide both the numerator and the denominator of this expression by 2, and we get that minus 2 over 2 is minus 1, and 2R square over 2 is R square. So in conclusion, we found out that according to equation 2, cosine y equals to 1 minus 1 over R square. But we already found out that y equals to 90 degrees minus 6. We already found out that y equals to 90 degrees minus 6. So can I tell that y equals to 90 degrees minus 6. Moving to question 1. And according to equation 1, according to equation 2, cosine y equals to 1 minus 1 over R square. So now we can substitute y in this equation, equation 2, by 90 degrees minus 6, from this equation, equation 1. We do it now, and we get that according to equation 2, we have cosine y, and y, so it is cosine y, and y is 90 degrees minus 6, and according to this equation, equation 2, this equals to 1 minus 1 over r squared. We have the trigonometric identity. It says that sinus x is equals to cosine 90 degrees minus x. And therefore, we can substitute cosine 90 degrees in this equation 2 by sinus x. We'll do it now, and we get that according to equation 2, we have here cosine 90 degrees minus x. It is sinus x according to this trigonometric identity. So we substitute cosine 90 degrees minus x by sinus x. So it is sinus x, and it is equals to 1 minus 1 over r squared. This is according to equation 2, while according to equation 1, we have already found out that cosine x equals to 1 minus 2 over r squared. So we have the two expressions of sinus x and cosine x. And we also have the trigonometric identity. It says that sinus square x plus cosine square x is equals to 1. So here you can substitute in this trigonometric identity sinus x by 1 minus 1 over rx, because sinus x equals to 1 minus 1 over r squared, and substitute cosine x in this trigonometric identity by 1 minus 2 over rx by 1 minus 2 over r squared, because 1 minus 2 over r squared equals to cosine x. So we will do it now. In this way we get equation 3. According to equation 3, we get that we have sinus square x. According to this equation, sinus x is 1 minus 1 over r squared, and therefore sinus square x will be equal to 1 minus 1 over r squared squared plus cosine square x. Cosine x is 1 minus 2 over r squared, and therefore cosine square x will be equal to 1 minus 2 over r squared squared, and it is equals to 1. So here it is equals to 1. So if we found out that according to equation 3, 1 minus r squared plus 1 minus 2 over r squared equals to 1. Here we will define 1 over r squared as t. Again, according to our definition, t equals to 1 over r squared. So now we can substitute 1 over r squared in this equation by t. We do it now, and we get that according to this equation, equation 3, we have 1 minus 1 over r squared. 1 over r squared is t, so it is 1 minus t squared plus 1 minus 2 over r squared. Here we multiply this expression by 1. This is allowable to multiply anything by 1, but we not change the value of the expression by multiplying it by 1. So here we have this expression equals to 1 minus 2. It is 2 times 1 over r square. And 1 over r square is 2. So we substitute 1 over r square by t. So total, this expression equals to 1 minus 2t squared. And this equals to 1. So actually, according to equation 3, I found out that one minus t squared plus 1 minus 2t squared equals to 1. So here we'll open the brackets on this side of this equation, equation 3, and we get that according to this equation, equation 3, we have here 1 minus t squared. 1 minus t squared equals to 1 squared, this is 1, plus t squared minus 2t. We have also plus 1 minus t squared, 1 minus 2t squared, 1 minus 2t squared equals to 1 squared, that is 1, plus 2t squared, that is 4t squared, minus 2 times 1 times 2t. Minus 2 times 1 is 2, so 2 minus 2 times 2t is minus 4t, equals to 1. Here we have 1 on both sides of the equation, so 1 gets cancelled. After cancelled 1, this side of the equation 3 we left only with t squared plus 4t squared is 5t squared. And we have here minus 2t minus 4t is minus 6t. And we have also plus 1 is equals to 0. So, according to equation 3, we should found out that 5t squared minus 6t plus 1 equals to 0. So this is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula. X equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. Another specific quadratic equation, that is to say 5t squared minus 6t plus 1 equals to 0. The variable that we are looking for is t, so x equals to t, the coefficient a equals to 5, the coefficient b equals to minus 6, and finally the coefficient c equals to 1. So the only thing that is left to do is to put the data of our specific quadratic equation, this data inside this general formula for x, and this way we find out the value of the values of t, because x equals to t. So we do it now, and we get here that x equals to t, so we substitute x by t. So t equals to minus b. b is minus 6, therefore minus b is minus 6, that is plus 6, plus minus square root of b squared. b is minus 6, therefore b squared is minus 6 squared, that is 36, minus 4 times a. a is 5, so minus 4 times 5 is minus 20, times c. c is 1, so minus 20 times 1 is minus 20, so inside the root we left only with 36 minus 20, divided by 2a. a is 5, so 2 times a is 2 times 5, that is 10. So she found out that t equals to 6 plus minus, and inside the root we have 36 minus 20 is 16, divided by 10. So we should found out that t equals to 6 plus minus square root of 16 over 10. So t equals to 6 plus minus the square root of 16 is 4 divided by 10. So here we have two solutions that are possible for t. The first solution for t is that t equals to 6 plus 4 divided by 10. 6 plus 4 is 10, and 10 over 10 is 1. So according to the first solution for t, we found out that t equals to 1 from one side, but from the other side, according to our definition, t equals to 1 over r squared. Now we can substitute t in this equation by 1 over r squared. We do it now, we get that 1 over r squared equals to 1. Here we multiply the equation by r squared, and finally we get that r squared equals to 1. Here we take a root out of this equation and finally found out that the radius r equals to the square root of 1, that is 1. So if we found out that the radius r of this circle, that is the radius that we are looking for in this question, the radius r equals to 1. But actually it is impossible that the radius of this circle equals to 1. Why? Because of the fact that we know that the length of the chord dB is 2. So dB equals to 2 units in its length. Chord dB equals to 2 units in its length. Again, chord dB equals to 2 units in its length. And chord dB is definitely not the diameter of this circle. Again, chord dB is definitely not the diameter of the circle. And we know that the diameter of any circle is the longest chord in the circle. Again, the diameter of any circle is the longest chord in the circle. And the diameter of this circle is 2r, of course. So the diameter 2r of this circle must be greater than dB, that is not the diameter, because of the fact that the diameter of any circle is the longest chord in the circle. Therefore, the diameter 2r of this circle must be greater than dB, that is not the diameter. And dB equals to 2. From this inequality, we will derive that 2r is greater than 2. We will divide this inequality by 2, and finally we get that 2r over 2 is r, is greater than 2 over 2 is 1. So in conclusion, we shall find out that the radius r of this circle must be greater than 1. If the radius must be greater than 1, the radius cannot be equal to 1. So we cancel this solution, and then we have to live with the second solution that is possible for t. The second solution for t is that t equals to, here, t equals to 6 minus 4 over 10. 6 minus 4 is 2, and 2 over 10 is 1/5. So t equals to 1/5. So actually found out that according to the second solution for t, t equals to 1/5. But according to our definition, t also equals to 1 over r squared. So now we can substitute t in this equation by 1 over r squared. We'll do it now, and we get that 1 over r squared equals to 1/5. Here we cross multiply this equation, and we get that r squared equals to 5. Here we take a root out of this equation, and finally we get that the missing radius r, the radius that we are looking for, it is equals to either square root of 5 units in its length, or in terms of numbers, it is equals to 2.236 units. bit again, we should find out that the radius r of this circle is equal to either the square root of 5 units in its length, or in terms of numbers, the radius r of this circle is equal to 2.236 units in its length. So in the next step, I'll summarize the lecture. In this lecture, we found out the radius of this circle. So in the drawing, we have a circle, and we have also, this is called dB. The length of called dB is 2, and this is called AC, and the length of this called AC is called of 2 units. In addition, we have called AB and called DC, and we also have this angle. This is actually angle DEB. The size of angle DEB is 45 degrees. Again, our mission is to find out the radius of this circle. In the first step, we join points D and A together by straight line. By joining points D and A, we created this peripheral angle. This is peripheral angle DAB. We define the size of this peripheral angle DAB is x over 2. And this peripheral angle DAB is subtended on chord DB. Again, peripheral angle DAB is subtended on chord DB. In the next step, we define the center of this circle. This point is point O. And then we join points O and D together by a straight line, and we also join points O and B together by a straight line. By doing this construction, we created the center angle DOB. This is the center angle DOB, and the center angle DOB is subtended on chord DB. Again, center angle DOB is subtended on this chord called DB, exactly like peripheral angle DAB, that is also subtended on the same chord called DB. So now we can implement all 13 in our drawing. Repeat quickly on all 13. According to rule 13, the exterior angle of a triangle, rule 13, according to rule 13, a certain angle is twice as large as the peripheral angle subtended on the same chord. So in the drawing we have a circle, and we have, this is peripheral angle ACB, and the size of this peripheral angle ACB is theta, and this peripheral angle ACB is subtended on chord AB. Likewise, we have also here certain angle AOB. This is certain angle AOB that is subtended on the same chord called AB. And therefore, according to this rule 13, the size of the certain angle AOB is twice as big as the size of the peripheral angle ACB that is subtended on the same chord called AB. The size of peripheral angle ACB is theta, and therefore the size of the certain angle AOB that is subtended on the same chord called AB must be equal to 2 theta. So we can actually implement rule 13 in our drawing. Why? Because in our drawing we have peripheral angle DAB is subtended on chord DB, and the size of peripheral angle DAB is x over 2. And therefore, certain angle DOB that is subtended on the same chord called DB must be equal to x, exactly twice as large as the peripheral angle DAB that is subtended on the same chord called DB. And therefore, the size of certain angle DOB must be equal to x. Likewise, we define this, the size of this peripheral angle ADC. We define the size of this peripheral angle ADC is y over 2. Then we join points O and C together by straight line, and join points O and A together by straight line. By doing this construction, we get the straight triangle AOC. Straight triangle AOC is subtended on chord AC. Again, this is straight triangle AOC, and this straight triangle AOC is subtended on chord AC. And therefore, according to Rule 13, because of the fact that those two angles, they are both subtended on the same chord, chord AC, the size of this triangle must be twice as large as the size of this peripheral angle. And the size of this peripheral angle is y over 2, and therefore the size of this triangle AOC that is subtended on the same chord, chord AC must be equal to y. Okay? According to Rule 13, of course. Now, in the next step, actually, I copied triangle AED in the new page, and then we implemented Rule 4 on this triangle, triangle AED. Actually, this is triangle AED or DEA, that according to the original drawing. The size of this angle is y over 2, the size of this angle is x over 2, and this is angle BED, the size of this angle BED is 45 degrees. Angle BED is located outside triangle AED, and therefore this angle AED is defined as an external angle in relation to this triangle, triangle AED, while those two angles x over 2 and y over 2, they are both located inside triangle AD, and therefore they are defined as the interior angles of this triangle, triangle AED. This is angle AED. This is also defined as interior angle of this triangle, triangle AED. In the next step, I actually presented to you Rule 4 and implemented Rule 4 in this triangle, triangle DEA. Now, if we click on Rule 4, according to Rule 4, the exterior angle of a triangle is equal to the sum of the two interior angles that are not adjacent to it. So in the drawing we have a circle. Inside the circle we have those three angles, A, B, and C. They are all defined as the interior angles of this triangle, while this is angle E, that is outside this triangle, and therefore this angle E is defined as an exterior angle of this triangle. And according to this rule 4, the size of this exterior angle E is equal to the sum of the two interior angles that are not adjacent to it. Angle C is definitely adjacent to angle E, and the two other angles that are not adjacent to it are A and B. And therefore, according to this rule 4, the size of angle E equals to A plus B, that is the sum of the two interior angles, the sum of the two interior angles that are not adjacent to it. Again, according to Rule 3, the size of the exterior angle, according to this rule 4, the size of this interior angle E is equal to the sum of the two interior angles that are not adjacent to it. And that's actually A plus B. So, angle E equals to A plus B, according to this rule 4. So we can actually implement Rule 4 in our drawing. Why? Because in our drawing we have, this is the exterior angle BED. The size of the exterior angle BED is 45 degrees. According to Rule 4, the size of this interior angle BED is equal to the sum of the two interior angles that are not adjacent to it. This is angle DEA, that is definitely adjacent to angle BED. The two other angles that are not adjacent to it are x over 2 and y over 2. Those are the two angles that are not adjacent to this angle BED. So according to rule 4, the size of angle BED is equals to x over 2 plus y over 2. Again, according to rule 4, the size of the angle angle BED is equals to the sum of the two angles that are not adjacent to it. That is to say, it is equals to x over 2 plus y over 2. But angle DEB equals to 45 degrees, so we can substitute angle DEB by 45 degrees, and we get that 45 degrees equals to x over 2 plus y over 2. Here we multiply this equation by 2, and finally found out that 45 degrees times 2 is 90 degrees, x over 2 times x is x, y over 2 times y over 2 times y is y. So in total we found out that 90 degrees equals to x plus y. We supply the x from this equation and finally found out that y equals to 90 degrees minus x. Okay. In the next step, I presented to you the law of cosines and implemented the law of cosines in this triangle DOB. So a bit quickly on the law of cosines. The law of cosines is through an triangle. So this is triangle ABC that could be any triangle. A triangle ABC, the size of side AB is A, side AC equals to B units in its left, side BC equals to C units in its left, and this is angle BAC, the size of angle BAC is theta. According to the law of cosines, in this triangle that could be any triangle, the following equation will be true. That cosine theta equals to A squared plus B squared minus C squared over 2 times A times B. Again, cosine theta equals to A squared plus B squared minus C squared over 2 times A times B. We can actually implement the law of cosines in this triangle DOB. So comment this triangle DOB in your page and implemented the law of cosines in this triangle DOB. But we know that DO equals to OB equals to OC equals to OA. They are both all the area of the circle. This is equals to R according to our definition, and therefore all of them are equal to R. Okay, so actually this is triangle DOB that is according to the original domain. Again, side DO equals to side BO equals to R, and it is given as the question that the length of side DB is 2. This is again DOB, the size of angle DOB is x. So according to the law of cosines in this triangle DOB, cosine x equals to DO square. DO is R, therefore DO square is R square, plus OB square. OB is R, therefore OB square is R square, minus DB square. DB is 2, therefore DB square is 2 square, that is 4. So in total we found out that cosine x equals to R square plus R square minus 4 over 2 times OB. OB is R, so it is 2 times R, times DO. DO is R. So in total, the denominator we have 2 times R times R. So conclusion, according to the law of cosines, we found out that cosine x equals to R squared plus R squared minus 4 over 2 times R times R. R squared plus R squared is 2R squared, so in total, in the denominator of this expression, we have 2R squared minus 4 over 2 times R times R, that is 2R squared. So here we have, so cosine x equals to 2R squared over 2R squared is 1, and here we have also minus 4 over 2R squared. Here we divided both the numerator and the denominator of this expression by 2, and finally found out that minus 4 over 2 is minus 2, and 2R squared over 2 is R squared. So in total we found out that cosine x equals to 1 minus 2 over R squared. This is according to equation 1. In the next step, I copied this triangle AOC in the new page, and we implemented the law of cosines in this triangle AOC. So actually, this is triangle AOC that I copied from the original domain. In this triangle AOC, side AO equals to side CO, they are both the area of the circle, is equals to R, and the length of side AC is equal to 2, and this is again AOC, that is equals to Y. So according to the law of cosines in this second triangle AOC, cosine y equals to AO square. AO is out, therefore AO square is R square plus CO square. CO is out, therefore CO square is R square. So it is R square plus R square minus AC square. AC is square root of 2, therefore AC square is square root of 2 squared, that is 2. So in total, in the numerator we have R square plus R square minus 2 over 2 times AO. AO is R. Substitute AO by R, so it will be 2 times R times CO. CO is also R, therefore substitute CO by R. So in total, in the numerator we have 2 times R times R. So according to equation 2, we should find out that cosine y equals to R square plus R square, that is 2R square, minus 2 divided by 2R square. 2R square over 2R square is 1, and we have also minus 2 over 2R square. We divided both the numerator and the denominator of this expression by 2. And finally found out that minus 2 over 2 is minus 1, and 2R square over 2 is R square. So in total, we should find out that cosine y equals to 1 minus 1 over R square. This is according to equation 2. Right. Again, according to equation 2, we should find out that cosine y equals to 1 minus 1 over R square. But we have already found out that y equals to 90 degrees minus x. And according to equation 2, cosine y equals to 1 minus 1 over R square. So now we can substitute y in this equation 2, y 90 degrees minus x. We did it, and found out actually that cosine y, and y is 90 degrees minus x, equals to 1 minus 1 over R square. Here we know that we have the trigonometric identity that states that sinus x equals to cosine 90 degrees minus x. Therefore, we can substitute cosine 90 degrees minus x in this equation 2 by sinus x. We did it, and here cosine 90 degrees minus x is sinus x, and sinus x equals to 1 minus 1 over R square. This is according to equation 2, while according to equation 1, we have found out that cosine x equals to 1 minus 2 over R square. So we have the expression for sinus x in terms of R, and the expression of cosine x also in terms of R. Now we have the trigonometric identity that states that sinus square x plus cosine square x equals to 1. So we can substitute sinus x in this trigonometric identity by 1 minus 1 over R square, and we can substitute cosine x in this trigonometric identity by 1 minus 2 over R square. So in this way we created equation 3. According to equation 3, we have sinus x, and according to this equation, sinus x is 1 over minus 1 over R square, and therefore sinus square x will be equal to 1 minus 1 over R square squared plus cosine square x. Cosine x equals to 1 minus 2 over R square, and therefore cosine square x will be equal to 1 minus 2 over R square squared, and it is equals to 1. In the next step, we defined t as 1 over R square. Now we can substitute 1 over R square in this equation 3 by t. We did it, and we actually found out that according to equation 3, we have here 1 minus 1 over R square, and 1 over R square is t, so we substitute 1 over R square by t. So this expression in total will be equal to 1 minus t square, and we have also here plus 1 minus 2 times 1 over R square. So it will be 1 minus 2, and 1 over R square is t. So we substitute 1 over R square by t. So this expression in total will be equal to 1 minus 2t squared equals to 1. So if we found out that 1 minus t squared plus 1 minus 2t squared equals to 1. Here we open the brackets of this equation 3, and actually found out that 1 minus t squared equals to 1 squared, that is 1, plus t squared minus 2 times t, and we have also 1 minus t squared, 1 minus 2t squared, 1 minus 2t squared equals to 1 squared, that is 1, plus 2t squared, that is 4t squared, minus 2 times 2t, that is minus 4t, is equals to 1. Here we have 1 on both sides of the equation, so 1 we get cancelled. After we cancel 1, for this equation, in this side of the equation we have t squared plus 4t squared is 5t squared, and we have minus 2t minus 4t is minus 6t, plus 1 equals to 0. So actually found out that according to equation 3, 5t squared minus 6t plus 1 equals to 0. So this is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula. X equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. In our specific quadratic equation, that is to say 5t squared minus 6t plus 1 equals to 0, the variable that we are looking for is t, therefore x equals to t. The value of the coefficient a in this quadratic equation, the value of coefficient a is 5, coefficient b equals to minus 6, and coefficient c equals to 1. And the variable that we are looking for is t, therefore x equals to t. The only thing that is left to do is to put the data of this specific quadratic equation, this data inside the general formula for x, and in this way we find out the value of the values of t, because x equals to t. So we did it, and we substitute x by t. So t equals to minus b, b is minus 6, therefore minus b is minus 6, that is plus 6, plus minus square root of b squared. B is minus 6, therefore b squared is minus 6 squared, that is 36, minus 4 times a. A is 5, so minus 4 times 5 is minus 20, and minus 20 times c, that is 1, minus 20 times 1 is minus 20. So inside the root we have 36 minus 20 divided by 2a. A is 5, therefore 2 times a is 2 times 5, that is 10. So inside the root we have 36 minus 20, that is 16. So we found out that t equals to 6 plus minus square root of 16 over 10. So t equals to 6 plus minus the square root of 16 is 4, so in total t equals to 6 plus minus 4 over 10. So here we have two solutions that are possible for t. The first solution for t is that t equals to 6 plus 4 over 10. 6 plus 4 is 10, and 10 over 10 is 1. So according to the first solution for t, t equals to 1 for one side, but for the other side, according to our definition, t equals to 1 over r squared. So we can substitute t in this equation by 1 over r squared. We did it, and actually found out that 1 over r squared equals to 1. And we multiply this equation by r squared, and finally found out that r squared equals to 1. Here we took out of this equation, and finally found out that the radius r, the radius that we are looking for, equals to the square root of 1, that is 1. So we found out that the radius of this circle, the radius r equals to 1. But it is impossible that the radius of this circle is equals to 1. Why? Because of the fact that we know that chord dB equals to 2 units in its length. Again, chord dB equals to 2 units in its length. And we know that chord dB is not the diameter of this circle. Again, chord dB is definitely not the diameter of this circle. And we know that the diameter of any circle is the longest chord in the circle. Again, the diameter of any circle is the longest chord in the circle. The diameter of this circle is of course 2r. So the diameter of 2r must be bigger than dB, that is not the diameter. Again, the diameter 2r of this circle must be bigger than dB, that is not the diameter. Okay? 2r must be greater than dB, that is not the diameter, and dB equals to 2. For this inequality, we will derive that 2r is greater than 2. We divided this inequality by 2, and finally found that 2r over 2 is r, and 2 over 2 is 1. So we actually found out that the radius of this circle r must be greater than 1. If the radius r must be greater than 1, the radius cannot be equal to 1. So cancel this possibility. This solution is the correct solution, and we left only with the second solution for t. The second solution for t is that t equals to 6, here t equals to 6 minus 4 over 2. 6 minus 4 is 2. 6 minus 4 over 10. 6 minus 4 is 2, and 2 over 10 is 1/5. So we found out that according to the first solution for t equals to 1/5. Again, t equals to 1/5 from one side, but from the other side, according to our definition, t equals to 1 over r squared. So now we can substitute t in this equation by 1 over r squared. We did it and found out that 1 over r squared equals to 1/5. Because multiplied this equation and finally found out that r squared equals to 5. Here we took out of this equation and finally found out that the radius r on this circle, that is the radius that we are looking for, it is equals to either the square root of 5 units in its length, or the radius r of this circle is equals to 2.236 units. I repeat again, the radius of this circle r equals to either the square root of 5 units in its length, or in terms of numbers, it is equals to 2.236 units. Okay, thank you very much.